Today we're looking at notes 3-2, solving linear systems using elimination. So with elimination, you get rid of one of the variables by adding or subtracting equations. You may have to multiply one or both of your equations by a number to create variable terms that can be eliminated. So here are your steps for solving systems using elimination. Get both equations in standard form, ax plus by equals c if not already. Stack the equations on top of each other so that like variables and constants line up. Check to see if one of the variable terms could be eliminated by adding the two equations. If not, multiply one or both of the equations by a number to create a variable term that can be eliminated. Add the two equations and solve for the non-eliminated variable, and then plug your solution into either of the two original equations and solve for the other variable. Remember, when we're finding a solution to a system of equations, we're looking for a coordinate, so both an x and a y value. So look at number 1. Let's start. So is or are both equations in standard form? Ax plus by equals c, ax plus by equals c, yes. Are the equations stacked on top of each other so that like variables, x's, y's, and constants line up? Yes. Check to see if one of the variable terms could be eliminated by adding the two equations. So if I add 2x plus 4x, will x be eliminated? No. If I had negative y plus y, will y be eliminated? Yes. Okay, so they can be, so then add the two equations and solve for the non-eliminated variable. Okay, so if I add these two equations, like I said, 2x plus 4x would be 6x. Negative y plus y would eliminate, and that would equal 0 plus 12, which would be 12. So then I can go ahead and solve for the non-eliminated variable. I would divide both sides by 6, and I would get x equals 2. Then I need to plug my solution into either of the two original equations and solve for the other variable. So I'm going to work with the top equation because I have smaller numbers. So 2 times x, which is 2, minus y equals 0. So 4 minus y equals 0. I'll add y to both sides. Move it to the other side. So 4 equals, that'll become positive y. And I'm done. I've found my other variable. So my coordinate or point of intersection, my solution, would be the coordinate x is 2, y is 4. If I were to graph these two lines, that would be their coordinate of intersection. Okay, look at number 2. So again, going through those steps. Are my equations in the correct form? Ax plus by equals c, ax plus by equals c, yes. Do my like variables and constants line up? X's, y's, equal sign, numbers, yes. So then if I went to add these two equations, would one of the variables eliminate? 5x plus 4x is 9x. Negative 3y plus negative 6y would be negative 9x. So would that eliminate? No. So then, if not, multiply one or both of the equations by a number to create a variable term that can be eliminated. So what I notice here is 3 divides into 6. 4 doesn't divide evenly into 5, and vice versa. 5 doesn't divide evenly into 4. So since 3 divides evenly into 6, I know that I could multiply this equation not by 2, because if I multiply by 2, that would still be a negative 6. I need to multiply this equation by negative 2. Here's why. Okay, as I'm writing this out, if I multiply negative 3y by negative 2, that'd be positive 6y, and positive 6y would eliminate with negative 6y if I went to add them. So I'm going to make sure that I distribute into all three terms. So this would become negative 10x plus 6y equals negative 36. I'm going to keep the bottom equation the same. 4x minus 6y equals 0. And now I'm going to add. When I add these two up, I get negative 10x plus 4x is negative 6x. These eliminate. and I get equals negative 36. So then when I divide by negative 6, divide by negative 6, I get x equals a negative divided by a negative is a positive 6. So then, and always remember, when you plug in this variable into an equation, plug into one of the original. Don't go to what we multiplied into, go to the original. And I'm going to pick the bottom because the numbers are smaller. So 4, where I see x, 6 minus 6y equals 0. So now I'm solving for that y. So 24 minus 6y equals 0. I'm going to go ahead and move over the negative 6y to make it positive. So 24 equals 6y. Divide by 6, divide by 6. I would get y equals 4. So my coordinate or point of intersection would be 6, 4. All right, last one. So on this equation, first thing I notice right away, my variables and numbers are not lined up. This top equation is not in ax plus by equals c form. I notice that these two actually need to be switched. So this would become 3x. When I move that guy over, it's going to become plus 7y equals positive 15. And then this bottom equation is in the correct order. 5x plus 2y equals negative 4. Okay, and as I'm looking at these two equations, I'm noticing, if I were to add, nothing would eliminate. And unfortunately, none of these divide into each other, none of these divide into each other evenly. So that means this is one of those, if not, multiply one or both of the equations by a number. So I'm going to have to multiply both equations by something to get one of the variables to eliminate. I also notice that both variables are positive here, both variables are positive here. That means I'm going to have to multiply one of my equations by a negative. So it doesn't matter if you want to eliminate x or y, okay? I can multiply the top by 5 and the bottom by 3, but one of them needs to be negative to make this 15, one of them positive, one of them negative. And I can multiply the top by 2 and the bottom by 7 to make both of these 14. Again, you have to multiply one of them by a negative to make one of them eliminate. It doesn't matter which choice you choose. I'm going to go ahead and I'll multiply the top by negative 5 and the bottom by positive 3. So that negative 5 will distribute in, and the 3 same will distribute in. So I'm going to write it over here. So I would have negative 15x minus 35y equals negative 5 times 15 is negative 75. And then distributing the 3 in, that's 15x plus 6y equals negative 12. So now when I go to add, my x's will eliminate. So those eliminate. I would have negative 29y equals negative 87. Okay, divide both sides by negative 29, and you would get y equals positive 3. Okay, 3 times 29 would get you back to 87. Okay, so that's my y variable. Now I've got to go ahead and plug that into one of my originals to get my x. So I'll go ahead and use the bottom equation. In this case, I would have 5x plus 2y, y is 3, equals negative 4. Okay, so 5x plus 6 equals negative 4. I'll move that 6 across the equal sign. So 5x equals negative 10, right? Because that would become a minus 6, and negative 4 minus 6 would be negative 10. divide both sides by 5, I'd get x equals -2. So our coordinate of intersection for these two lines would be x first, -2, comma 3. And you can try 4 on your own if you wish. That's all for today.